This is the velocity problems. For example 2, we have a ball is thrown into the air with a velocity of 40 feet per second. Its height in feet t second later is given by that function right there, 40t minus 16t squared. And we want to find the average velocity of the time period beginning when t equals 2. And lasting for each time elapsed right there. So first of all, let's take a look at the equation for average velocity, which is the change in position over time elapsed. And I put y of t because that's the function of t. So first, what is the average velocity for this particular problem? So let's say if we have the time elapsed is h, then change in position will be y of 2 plus h minus y of 2, because t is 2 for this case. And then we have 2 plus h minus 2. All right, so let's take a look at y of 2, and then we can plug it in later. So y of 2, we're just going to solve for it. So 40 times 2 minus 16, 2 squared, it's going to be 16. Now, let's look at the average velocity. So what I have, y of 2 plus h, what is it? It's going to be 40 multiplied by 2 plus h minus 16, 2 plus h squared. And then minus y of 2, and y of 2 is 16. All right. Everything over 2 plus h minus 2, which is just h, right? So if you FOIL and you multiply it out, you simplify, we're going to end up with negative 24h minus 16h squared over h. When you simplify one more time, we're going to end up with negative 24 minus 16h. All right, so let's calculate for 0.5 second. So for 0.5 second, which is the interval 2 and then 2.5. Okay. So in this case, h is 0.5. Right? So we just plug it in. We're going to get negative 24 minus 16 times 0.5. You will see that it's going to be negative 32 feet per second. And then if we keep doing it for 0.1, we're going to get negative 24 minus 16, 0.1. If you calculate, you're going to see negative 25.6 feet per second. Let me jump over. I keep this for now. Okay, so for C, we have 0.05 for H. It's going to give us 16.0.05. It's going to give us negative 24.8. And last but not least, we have 0.01 for h. If you calculate that, we're going to get negative 24.16 feet per second. Okay, now let's take a look at the instantaneous velocity when t equals 2. So we want to estimate the instantaneous velocity. When t equals 2, which is defined by the limit values of these average velocity over shorter and shorter time periods that start at t equals 2. So as you can see, we go from negative 32, and then we go to negative 25.6, and then we go negative 24.8, and then we're getting smaller and smaller and closer. Okay, so you can see that if as h approaches to 0, the instantaneous velocity when t equals 2 is going to be negative 24, because the limit approaches to negative 24.